that were here last week, so we did cover a bit of the introductions to Linux. So this quote was chosen because Richard Stallman is the creator of the GNU Toolkit, which is a core component in Linux. So brief overview of what we saw last week. So we defined what was Linux and the common distributions. Also, we checked out on what could be the uses, general uses for Linux. Then we continued on why we would use Linux in cybersecurity. And a bit of that. So we talked about Richard Stallman. Maybe you saw his pictures in history book. Apart from that, so we did a bit of history, compared Linux and Windows, which are two very common operating systems. And, memes. I like my memes. Then we talked a bit about the file system. So this is just a quick enumeration of the folders that you could see in the file system. There are others, and if you guys want a more detailed explanation, this is available on the slides, and you can go check it out more in details. Then we talked about packet managers. So on Apple, you got Apple Store. On Windows, you might do it with the Microsoft Store or might download stuff. In Linux, you do have stuff that is called packet managers. So a very famous one on Mac is Homebrew. But one that you will probably see on Linux will be apt. So you might see some stuff like apt install, sudo apt get, things like that, to get some updates for your distro. And anything regarding that matter, you would use a packet manager like apt or one of those in this list that is non-exhaustive. So we also talked a bit about what is a process. Each process has an ID. Processes are a program that is running. You could call that a process. The ps command enables you to check what processes are running on your distro in Linux. Then we talked about the states that a process could have, so running, waiting, stopped. The shells, because Linux doesn't have a single shell, it has a lot of shells. You can download put whatever shell you want. The initial one was sh, which was quickly replaced by bash. And my favorite one is SZSH. But you do have a lot of others like fish, KSH, things like that. They do have their inconvenience and their the things that they're good at. Bash being the default one has the most general usage you would like. Fun fact, if you want to change to whatever shell you want, you can use this command, chsh. We saw how to navigate the file system using commands like pwd, ls, cd, and cat. Cat being for reading files, cd being for changing directory, like it's like cd. ls being for listing, so you might see some stuff using ls. pwd, print working directory. So one thing that you might ask yourself is, why do we want to see what directory we're at if most of the time we can see it in the terminal input that we have? And this comes, in our case, for shells. So most of the shells you might want to do, like a reverse shell or a bind shell, will not be interactive. So you will only have a blank space where you will type your command, no tab to autocomplete, no nothing like that. And sometimes you might not know where you are, or you might want to drop a file somewhere specific. And pwd enables you to see where you are when you don't have any interactiveness except command. So ls command, very, very famous one, enables you to see everything, permissions, users, groups. You can list their directories. I mean, you can do everything. Uname to check your kernel and systems configuration. So you might see the host name, your kernel version, what you're using, your architecture at the end. x86 64 is your architecture, anything like that. So then you can manipulate file with these commands that we checked out and that we did in the workshop. Permissions, very important. So you do have file permissions, but we also talked about that last week. Read, write, execute, or owners, groups, and others have read, write, execute permissions. Chmod to change those permissions for a file that you create or that you would like to modify. So you might have already a written script, but you might download something for the internet, but they will tell you execute this file, but your file doesn't have executable permission. So you have to chmod to add the executable bit to this file so you can then execute it. So yeah, okay, quick. So that's what we saw last week. I think this will be the video, which I will skip over. Sudo, very important. Sudo super user do gives you the root privileges for anything that you need, and without having the root account. So the root account will have privileges over everything. Sudo, you can set sudo permissions for specific files. So I might want to read a a specific file, but I don't want the user to have any other privileges than that, then I would probably give him a sudo access on the cat command to only be able to read with super user privileges. But if I do that, he'll be able to read anything with super user privileges. So that's where permission control comes in a very important manner. You need to know and have a very granular control of your permissions, which we will see a bit later. So user account management, you have all these commands that I will not go over that enables you to manage a user. Very important, etc. So the shadow file and the password file. So password, named password, PASSWD, doesn't have passwords. Why? Don't ask me why, but it is how you would probably remember that. You have a file name password, doesn't have passwords. It has users, so you might see which or who is the users, their full names, their ID in that file, and it's accessible to everyone. But the real juicy content is in etc shadow. Shadow, why shadow, I don't know, but this is where you have the hash of the password that are stored. And this is only accessible by root or if you have super user access. All clear? Perfect. So this was another video to show you guys how we did account management, but I think I covered it last week. If we have a bit of time, we'll review everything. I'm not going to spend too much time. And this is where we resume. So, Bash shell and yes, go for it.
It's about the videos, yes, because I tried to download the slides, but when I tried to watch the video...
It says no permission?
Yes.
Okay, I will fix that just after this lecture.
Yeah, okay.
No worries. But it's very good that you tell me because I just realized that at the start. And that's a problem. So, so part of the things that you can do with a shell on Linux is do some networking. So check out what ports, open ports you have, see your IP address, your routes, check out your ARP table, all those things that we talked about a bit earlier this year. So you do have a few commands like that, IP ADDR or IP -A for if you want it shorter, shows the IP address of your interfaces. So if you have 20 interfaces, which is one access to a network per each interface, or you can have different IPs, like multiple IPs for a single interface. I'm going to skip all the details, but IPADDR is the command you would use to check that out. ifconfig would be to show the same thing, but on older systems. So if you type IPADDR, no results or unknown, then try ifconfig, probably will work. Hostname L, show your local IP address and the hostname if you have resolved the hostname. So we saw that an IP resolves to hostname. When you search for Google, you don't search for Google, you search for an IP that is resolved by something we call the DNS. So hostname, if ever you had a hostname, I don't know, I would call it mylocalmachine.local or something like that. This would show you that. If you don't, it'll show you your IP address. Then you can ping, as we talked a bit also earlier. Ping, check out if something's online or not. IP route show, display your routes, your IP routes. So your routing table is very useful when you try to add multiple interfaces or tweak your VM networks. You might need to check out this command, and it will show you a lot of things that you might not have known about your computer. And my favorite one, netstat -TULN. Don't ask me what it stands for, I don't remember exactly, but this is to show you your active open listening ports. So the L probably stands for listening, but apart from that, this is crucial when you want to know what is open on your machine. So normally, if you open something specifically to test it, like FTP server or SSH, you will see open ports, and the name or the number of your ports and what service is running. So this, if you want to diagnose your machine, is a very important command to know. So now we are going to go more in detail on the IP address command. You can show your IP addresses, of course, but you can show a lot of things. So your network interfaces with link, your IP addresses, APDDR show or IP-A for the simpler one. IP route show, so you can see your routing table. You can add something to your routing table. You can delete an entry for your routing table. And you can set interfaces online or offline as well. So your usual one will probably be ETH0. So if you bring that down with the last command, for example, with this one, you would probably not be able to connect to internet if that was your only interface and the default one. But you can then put it up straight away again, and it will work like if nothing happened. Very important, these changes are not permanent. They apply to your current terminal session. So if you set that, you do big configuration, spend hours doing that, then you close the terminal and reopen it, all the changes are gone. So you have to set something definitively if you want to have these changes really hard-coded on your computer. So a definition for a network interface by Oracle is the point of interconnection between a computer and a private or public network, something that connects, that enables you to connect to a network. That's it. That's my definition. A bit simpler, maybe a bit too simple, but just see it as you might have multiple IPs that enables you to get connected to multiple networks. One of these IP is a network interface. So each IP is a network interface. You can have multiple, but it's not for right now. So one other thing we also talked briefly about is the curl command. The curl. So the curl stands for client URL. Enables you to transfer data or send requests on the internet. So HTTP, HTTPS, FTP, you can send wherever you want. You can send post requests, you can send get requests, you can send head requests, you can send delete requests. I mean, anything you want. Enables you to check out the headers of a web page when you don't have Burp Suite or anything like that, which is quite important. And you can show the response headers if you only want. You can download files with curl. You can save your files, download them and save them as custom name, or you can do a lot of things with curl. Anything regarding HTTP protocols and other online protocols, you will do with curl. So if ever you don't have Burp Suite or you don't have any tools that enables you to talk to a web page, curl will probably be your best friend. So, quick exercise to have you guys remind you guys of what happened last week and work a bit on what we talked right now. I'm gonna correct this quite quickly because it's a bit early in the lecture. But if you guys want to work together, just try to find out a few of what these commands might look like. So, display your current working directory is probably gonna be 2 letters, or maybe 2 letters of space and something if you want to make it complicated. But I'm not expecting you guys to build like absolute madness of commands. So just give it a go. If you have a piece of paper or if you want to chat and give me the answers live, go for it. I give you guys until 50, so 4 minutes if you guys are down. Thank you very much.
I think it there's also like yes, you can also like find where things are logging to, like find information about
There's also a file that has all of this calls. Current file name
X is different EDC.
Yeah, what do you name? What do you? How do you pronounce the folder EDC? You say EDC.
X is an X that hash table. That's what X is. So that's why I call it ETS.
So it's EDC.
Because X
I see.
is ETS, which is a hash table.
so password used to contain the password originally, and then they moved it because they thought if everyone could access the password, that's stupid.
Yeah.
Let's move it to a separate file. So people still need to know what.
And that's why in the password they put X to say
Yeah.
reference to.
It's reference to
So initially that was that.
Yeah.
Then-
I looked this up because I thought that is a bit stupid.
Yeah, but I didn't have time to look it up, and I didn't think about looking it up. But okay, it makes a lot of sense then.
The
Yeah.
original, had a password.
Okay. Oh, yeah, but it does make sense now that you explain it. Well then, thank you for teaching me something. Okay, I'm gonna start correcting some stuff. So, for the first one, to display your current directory, you would probably do pwd. So there are multiple options, like always. We're doing computer science and cybersecurity. There is probably 25 options to show your working directory, but pwd or ls space dot, which would show you exactly what is in your current working directory and your working directory, could be an answer. So list all files, then comes the ls command. So ls /la will show you absolutely everything you need to see, the hidden files and the permissions. So that's overkill for a command, but it does everything. Show your system IP configuration. So IPA or IPADDR show if you want the long version, but they do exactly the same thing. So I typically go for IPA because it's quicker. Create an empty file called notes.txt. Touch is something that you would use to create a file. Touch node.txt will help you create a file named notes.txt. Then you move a file named reports, to a directory home student documents. To move a file, you use MV. MV stands for move, and you can move something to a directory. And if you want to rename a file, you will also probably do it with move. It's not the next one; it's the one after. So to change a permission for a script and make it executable to the user, you would need to, in the case that you're not root, probably have super user privileges. So sudo, then you chmod, so change the permissions. And you for the user plus X for execute. So you add the executable permissions to the user and you put the file name after, sorted. Then, so the thing I was talking about before, with a move you can also rename files. So here I ask you to rename secret.txt to not secret.txt in a new location, and you can do it in one shot with the move command. So I move my initial file to the new path and the new name of the file. Show current running processes, PS or top. Top will display a dynamic list that will refresh every, every click or every certain number of seconds. And PS will show you just active running processes in one shot. So top, the output of top is a bit complicated to understand at the start, but PS will show you mostly what you want to see. Then test the network connection. We come back to our usual friend, the ping command, which shows you everything you need to know for a network connection. Displayed all the active network ports that are listening. I should have added listening network ports. But this is the netstat command. Just don't forget the -tuln at the end. But apart from that, you have everything. So, why do I go back? So that's new content that we didn't see last week, and I really wanted to introduce something called Linux services, even if it doesn't have really its place now, should have been talked about last week, but I could not talk about Linux without talking about services. So sometimes you might have a repo, a GitHub repo, or something that you would like to have automated on startup. So whenever you start your machine, you would like something to run. On Linux, this can be achieved with services. So Linux services are background programs, so also something that we call daemons. Daemons are, as the definition says, background programs that run and that monitor in the background, like really stuff behind daemons, that's it. So they run automatically and provide functionality. SSHD is the daemon for secure shell access. HTTPD is the daemon for a web server or Nginx. And SQLD is a daemon for database. I mean, you get the idea. And at the end, I added my custom service because you can make a fully custom service. So tell your service what permissions it can execute with, as what user he should do the task, what task he should perform, does he need to run a script, does he need to run an app, does he need to update your distro on startup. You can do anything you want in services and automate these tasks. So an example that I take from what I did last year when I had to work, I had to pull a branch very, very regularly, and I did that with a service. So luckily for me, the thing I was working on was a Raspberry Pi that was always plugged, so I didn't have to check whether it was offline or not. Knowing that it was always online, I just made a service that said every 30 minutes, pull from this branch. And after, I realized it was absolute shit because it pulled even if there was no changes. So I changed it, and I said every time you detect a change in the ID of the top branch, you pull, and it was better. But just to tell you guys that you can automate anything. You can pull from repos. You can download your latest updates automatically with services. So that's it. You control your services with systemctl, and you control a lot of other things with systemctl as well. But it enables you to check the status of your service, start and stop them, enable and disable them, which is not the same as start and stop. Enable and disable with enable them at boot and disable them at boot. Start and stop is for your current instance. So you might stop it right now, but it will still be enabled and run on your next startup. So what it matters, also services are, even if they give you a lot of access, they also give you a lot of vulnerability attack surface. So you give access to specific components with specific rights. If you use stuff that you shouldn't, if it has permissions that it shouldn't have, it is an exploitation vector. So you need to be very careful with that. So, standard streams. This doesn't look like the most interesting thing, but it is crucial for the rest of what we're going to do this year. So you have 3 streams that will enable you to interact with a computer. Input, output, error. That's it. So std in, input. First one. Second one, out, std out, output, stdr, error. So the numbers corresponding to these streams are 0, 1, and 2. Remember that, because in Linux, if you want to manipulate your streams, it is via the numbers. So you have a small description going next to that I'm not going to read, but you need to know that when you write a command on your shell, you write in the standard input. What you see on your shell after is the standard outputs, and if there's an error message showing, it's a standard error. Shows up for everyone, but you can manipulate these and send, for example, the errors of a command that you're doing in a file and keep the normal outputs to help you sort things out. So one other thing that is absolutely crucial that we talked really briefly about in the workshop last week is pipes and redirections. So firstly, here we only have redirections, but this is how you would probably have a command. So for example, ls, but you don't want your output to be displayed in your terminal. You want your output to be stored in a file. Then you would redirect std out that we just saw, so the standard outputs, to a file. And that's it. You have your stored output. Wonderful. Why do we double it up? Because we want to append. If you do the same thing again and you do use the single superior or symbol, then you will overwrite what you wrote before. So the double is just an append, which enables you to not overwrite what you've done before. So then to redirect std_in, which is the input, and wonderful inputs, you will use the inferior or sign, so don't get confused with the superior or inferior. And for example here, you would redirect the names of the file right here in the sort command. So your input for the sort command is going to be names because you redirect the std_in. All good? Perfect. Next two, quite important. So if you have a 2 and a superior or, it's redirecting the error outputs. So if you try to list files and you know you'll have a lot of errors, then you would probably use this to only get on your terminal the things that don't generate an error and send the errors to error.txt. Enables you to have a clearer view of what you're looking at and sort everything like that. And the last one, which doubles up, is the n% superior or, and that redirects std out and std error into a specific file or something. So most of your outputs, I mean, actually all of your outputs, because stdin, you will provide it. So this would be the same thing as not putting anything if you don't manipulate specifically a specific file. But if on your normal terminal, this is the output you get. So now pipes. This was before we saw redirections. Now we're going to talk about pipes. So a pipe is something that connects an output of a command to an input of another. So imagine I want to find a specific file, but I got thousands of files. If I do a ls, I'm going to scroll for 10 minutes until I find my file. That's not going to work. I want to see the specific permissions for this file. That's not going to work. So what you would do here, ls, pipe, so send the output of ls, and then grep, which enables you to find a string that corresponds to this in your output. So ls generates output, pipe, so send the output to grep, and in the output, try to find something that finishes by .sh, or that starts with .sh. Sorry. Is it clear? So pipes send the output of a previous command as input for the next command. And you can do pipe chains. So you can pipe something that pipes something that pipes something that pipes something. So this is very important if you want to do one-liners instead of doing 25 commands. So ls, then next line, then try to grab my file, then open my file, then do something. Pipe, single line, everything is absolutely sorted. So when combined with redirections of what we saw before, you can do very powerful one-liners. So you do have an example here. I want to list what is etc password, but in that password, I want to grep. So I want to find the specific lines of the users that are in and send them in this thing. So I'm going to cap my pass what the content of this file. So list the content of this file. The output of this is going to be sent in grep bash, so every users that have a bash terminal, and all these users are going to be sent as output in this file. So everything will be in bash users at the end. Why is it important to know that you can do a lot of things with redirections, and that is really where we start to talk about attacks in cybersecurity and vulnerabilities. So one thing that you cannot go about without when you talk about redirection pipes is something called a fork bomb. So you might have seen the meme where you have someone that tells you remove your all OS doing rm rf and slash. This is something that is classic trolling in cybersecurity, but this one much harder to understand what it is, but as dangerous and can literally crash your system if you don't have specific permissions that are set to restrict that. So this is a powerful, dangerous fork bomb. If you guys are asking what it is the symbols that are up there. So what that does is getting decomposed. First 2 points and the first parenthesis, they define a function, and the function is empty. So the function name will be colon in this case. Then you have I don't know the name in English. You have the pointy parenthesis. I don't know what they called, but you have the pointy parenthesis. And so this is where you define what this function is going to do. Column again, so the function calls itself. Then you have the pipe. So pipes the output of the first function to another one. Then you have another call to this function, and you have the %. So here the %, is used to background a process. So what you can do in Linux is, okay, I'm not finished on that. I want to finish it later. I don't want to kill my terminal. I background. Then I open it up later. So this is to background the process. Function definition is finished. Then I column to say I finish, and then I call this function. So this absolute killer of machines, if you want. This will spawn 2 more every time it's called, and it calls itself automatically. So you can probably tell that in less than a minute you will have a lot of processes, because if you spawn 2 more, that spawns 2 more, that spawns 2 more, that spawns 2 more, you get the idea. But we can protect yourselves from fork bombs, and you can set user process limits, which limits the user creation processes. So of course here 200 is the value I set, but you can set it as whatever you need when you on your operating system. So if you need to create a lot of processes, set it higher. If you don't never create processes, you can set it lower. But this will probably protect your machine from fork bombs. Now, shell scripting. So we saw that we could do a lot of things with shell, with bash shell. We saw that we could do one-liners. Now, what if I tell you we can do scripts? You're going to tell me I'm mad, but I'm going to tell you this is very, very cool for automation. So you can make shell scripts. These shell scripts are not like a specific programming languages. I mean, they are a bit of a programming languages, but you can use the commands that you normally use in your terminal in these scripts. So you can automate repetitive tasks, you can simplify administration, combine multiple commands, and for cybersecurity, you can really do whatever you want. And these link perfectly with services. So you can make a service that calls your script, so you can do things that are fully custom to your distro. But don't forget to make it executable, because a script that is not executable will not work. So, an example of a script. Can you guys spot the mistake in this code? There is one mistake that I did somewhere, and it's don't go looking too far. It's a dumb typo, but it is a mistake, and you will see that when I realized it when I was recording the video that I'm gonna show you guys next, and I mean it still works, but you do get an error. Any ideas for the mistake? It's a spelling mistake. Any idea?
Date meant to be capital.
No, exactly. Yeah, date is not meant to be capital. So there is sensitivity regarding capital letters and non-capital letters. So ls in caps will probably not have the same effect as ls in non-caps, or comments like that will do this. So the video here is just a quick demo of how you would do a script. Sorry for the absolutely horrendous quality. So you would go in the folder you want to create your script. Okay, quality seems to be better. And then you would, using your favorite text editor, write a file and add the .sh extension at the end to make it a shell script. So then I paste here, right here, I paste the content of what I showed you just before. And as you can see, I add hashtag !bin bash in front. This tells the compiler that this will be a bash language and this will be executable. So don't ask me why exactly is this structure. Bin bash just tells it that to use the bash binary, so which is a shell for compiling and executing this script. So this will just display system information if it worked properly. As you can see here, I do have my script, but my script is not executable. So I need to make it executable. So that's what I'm gonna do right now. Exactly. So now you can see it is green and wonderful, which means it is executable. And then I run this, and you can see I get part of what I wanted, but also at the same time, I do get an error. Here, I get my system info, but on line 4, when I tried to run dates, it said command not found, because it is very sensitive regarding caps or not caps. So I think, every time. Give me a second. My computer is absolutely dead. Okay, perfect. So let me just resume here. I think I do show you guys that the dates command runs. No, I do not show you guys that the date. Okay, well then normally the date command runs without caps. So this is a mistake that I made, but it can show you that you can make scripts to automate absolutely anything. Why do I bother you guys with all of this stuff about Linux? And why am I really spending some time on Linux, 2 lectures? Because firstly, it's open source, and most of the cybersecurity tools you will need will be on Linux, much more accessible than on Windows or Mac. But because once you understand something, that's where you can really try to exploit it or to use it to do something that it's not supposed to do. So you gotta understand, in cybersecurity, we don't ask you to be great at something. We ask you to have the mind to try and think like no one else would think. So I give you an Excel spreadsheet. You won't try to fill it up or fill the data. You will try to break it by sending random characters or doing things like that. You need to try to get something that you shouldn't be able to do with a program. So here, a small roadmap that you would do once you're given a machine and you have just access with no privileges, no nothing. So you have initial access. understand what is around you, try the commands, try to see what files you have, try to see where you are, what is writable, what is executable, what permissions you have, try to gain higher privilege, what we call is privilege escalation, and at the end, your final objective will probably most of the time be or a flag, so a file called flag or a flag value, or getting total control as root, so the super user. A bit more on privilege escalation. So privilege escalation is moving from a low privilege machine or a low privilege user to a higher privilege. This is vertical escalation, so you're getting higher and higher in the access pyramid, but you also have horizontal escalation where you move from side to side with the same privileges, but a machine might have a file that will enable you to get higher access than that another machine would not have. So sometimes you might have to pivot horizontally before you can pivot vertically. So what it matters in our case, when you have root, you win. You have everything you need. You have full control of any system of the system, and you can probably do anything you would like with the system. So one thing to note is that on Linux, what is called root is called on Windows anti-authority system. It is not exactly the same thing, but for what we are interested in, this is the root of Windows. But this is a Linux lecture, so I'll talk that on the Windows lecture. Now, a bit more about binds and reverse shells. So we saw what was a shell. Now, what if I told you you could open a shell on someone else's machine or on your machine that you don't have physically in front of you? As simple as that if you have the right tools. So a reverse shell is when you send when you have your machine and you have another machine. You are attacking the other machine. So you set up something that we call a listener. So you wait for the connection, and the machine you are attacking is the one that connects back to you. So that's a reverse shell. Then a bind shell is the opposite. You are the one connecting to the machine you're attacking. It's counterintuitive because most of the people would think bind shells are much easier to do and much safer, but actually it's the opposite. You will always have less worries to have about the firewall if you do a reverse shell, because if the machine that is already in the safe zone connects to you, it is much safer and much less considered as a hazard than if my machine, which is unknown to the system, connects to one of their machines. So reverse shells enable you to bypass firewall most of the times, or better, because you have some of them that will just not let you go. So just as a quick memo, who initiates the connection? If the server initiates the connection to the attacker, it is reverse. If the attacker initiates the connection to the server, it is bind. So what we use to do that, we can use multiple tools, and the list is big, but the most famous one is called Netcat, abbreviated NC on most Linux machines. So it's a simple Unix utility which reads and writes data across networks using TCP and UDP, back of the two protocols that we saw at the beginning of the year. So in our case, most of the shells that we will open are TCP shells, because UDP shells are a bit harder to open and less documented. So if anything happens on a TCP shell, most of the time you will have all the resources that you need to understand and debug that shell. So what you would use Netcat for is, apart from opening shells, you can do port scanning, banner grabbing, you can do some listeners, you can do some file transfers with your friend, or even quick chats between two computers if you guys know each other's IP, or if one connects and the other listens. You can make a private chat on a specific port of your computer, which I'm going to show you in a few minutes. There are variants: SOCAT, Netcat, NC, GNU Netcat. These are variants for Netcat, but you also have other tools that enable you to do that, and you can even do it manually. It's just very, very long. That's why we have tools to do it. And specific shells will not enable you to open reverse shells or bind shells as easy as other shells. So one inconvenience that breaks my heart to say, but when you use ZSH, which you will have difficulties, a bit harder time opening the TCP folder handler, because in ZSH it doesn't exist. But that's why I use Netcat, because it does everything for me. So it's very powerful. So I'm just going to start with the warnings, because now I'm going to start to teach you guys some stuff that you could use for malicious purposes. Very powerful, only used in an authorized lab environment or on machines that you own, or on your friends that are okay with that, of course. So, so just a bit more info about how to use Netcat and on comments that I described just before. So to do port scanning with Netcat, you would use NC. So NC stands for Netcat. Then a specific dash options. So here V is verbose, Z is 0 and IO mode, and you would put your IP or your host name followed by the port. This would tell you if the specific port you said is up or not. You have other tools to do it, but you can do it with Netcat if you want. Banner grabbing is just a way of saying grabbing the headers of a web page. If you want to check out what headers are running on a web page to see if you have some things that you can modify, a cookie or anything like that. Banner grabbing. So here I'm just sending empty HTTP requests. So with echo, E and all the thing until the pipe. And then I'm just piping that. So the output of this, which is an echo, which will just say the same thing, and piping that to Netcat on the port 80, which will probably be the HTTP port. And I'm gonna get results with a header of this page, and I send a head request, not a get request in this case, sorry, which will just give me the header. So you can do TCP UDP listeners. The L option stands for listen. If you just put the port after, this is very useful when doing a reverse shell. This is set up a listener, but you don't, most of the time you don't need to precise the P option, but in some versions you do. So I would suggest you just leave it here so you're safe. And you can transfer files between your friends with Netcat, which would probably seem, what we explained, you're just sending text through a shell to another guy that is piping that in a file. So sending a file here, Netcat, listen, port, so port 9000, redirect the output of what I'm gonna get in that in received.bin or receive.txt or wherever you want. Then the sender, initially, he will connect to the target, so the target IP will be the listener IP on the same port, and say that the input for this Netcat will be what was in his file.bin. So at the end of the day, listener will have the same file that the sender had and wanted to send. So how do you do reverse shell? How do you do bind shell? This is the very basic commands that you will probably see almost everywhere. Reverse shell with a tool like Netcat. So that is not good news. Sorry about that. Yes, okay, perfect. I'm very okay. So yes, local IP will stand for the IP you want to connect to. Port will stand for your port, and -E bin bash will say execute bin bash when there's a connection. So open a shell. Sorted. That's it. Attacker will just open a listener. Well, LVNP. V stands for verbose. L for listener. N for do not resolve the DNS host name. So because you're just sending an IP, which will make you save a bit of time. P for port. With all that, you can set up a listener. The other target will execute something on connection. And that's it, you have a reverse shell. And for a bind shell, is the other way around. So the target will open the listener. Here, eCMD is an example to say that you can specify what shell you want to open. On Windows, you would probably open cmd.exe or PowerShell. But on Linux, you will have bash, so go for bash. And then attacker will do the opposite. So we'll just connect to the target. Notes, important, if you're trying to bind something to ports that are under 1024, you will have to use sudo privileges because these ports are most of the time reserved for specific services. So quickly, an example of me setting a reverse shell on my home Raspberry Pi, just to show you guys. So this doesn't make a lot of sense in this case because I already have a connection, but you might imagine that I'm dropping a file on a web server that will then be executed that would give me a shell. So this is my attacker machine. So I can see here my IP, like I showed just before, the IP also of the target machine. So here I will just start a listener on this machine, which will be the attacker machine, and I'm just gonna put my hands behind my head and lie down on a chair waiting for the attacker to for the machine that I'm targeting to connect back to my listener. So here I can see it's acknowledged by saying listening on port 8080. And here, this is my target machine. So imagine I had a way to make him execute this command exactly, or by sending him a malicious file that he will execute, or by implementing something when he was not looking. And I'm just gonna do that, which will connect to this IP, which is the IP of the attacker, and on the port that he opened, and spawn a shell. So I am auto breaking my system, to say that. So by doing that, I connected. You can see on my attacker machine, it has acknowledged that I do have a connection. And if I ULS, I can see exactly what is on Enigma. So Enigma being the target machine. But as you can see also, the terminal is very ugly. It doesn't look very nice. You cannot see a lot of things. And it doesn't look very, very stable. And that's also a problem that we have when we spawn a shell and that we need to take into account. You will not have autocomplete. You will not see exactly where you are, except if you use print working directory, as I told initially, which will show you what you need to see in some cases, but you will miss a lot of things, and interactiveness does not come prepackaged when you just spawn a simple shell like that. So here I can see that I'm connected as Enigma, which is the target machine. I can see when I do print working directory that I am in the Enigma machine, but one thing that I want to check, it's not pause, no, is what if I try to use a sudo command that would prompt me for a password? Oh, I don't get an output. The output appeared on the target machine, which could be a problem, because if the guy is randomly on his computer, random password prompts pops up, he might start asking questions. But once I entered a password properly on my target machine, it was displayed here. But you see, as you can see, it works, but we want more stable shells and we want more interactive shells to have persistent access. This will do the trick initially, but then you would upgrade your shell to something where you have more control. And this will be a proper lecture by itself. So let's finalize some stuff and say that and explain why we already talked about Linux so much. What is this case of cybersecurity? So this is an image of very niche distros, except Kali, that are used for cybersecurity. Black Arch, if you guys are interested, good luck configuring that. You probably have the whole year in front of you, but even that's not going to be enough. And so why Linux is really important in cyber? Because you have all these type of vulnerability, as again, list non-exhaustive. A lot more than that, cron jobs and everything. But these are main vulnerabilities that you would probably find on a Linux system that would enable you to get full access, privilege escalation. Kernel level vulnerabilities, misconfigurations, SUID binaries, which is something with the privileges, capabilities, which is something that enables you to control very fine-grainedly who has access to what. So it's called capabilities. And you can, if a path variable is misconfigured, you can access that as well. Network file shares, you can mount negative file shares, things like that. And you have a lot more. So really Linux, being as customizable as it is, also comes with a lot of possibilities to mess up. So that's really why we're interested in that. How to protect yourself? I'm going to go quickly on that, but it does not come surprising for anyone that I'm going to tell you to use strong passwords. Multi-factor authentication, probably get told that every day nowadays, but at the same time, it is really what you can do. So keep your software updated as recent as possible, because most of the time you have vulnerability patches. Regular backups, always very nice. For networks, use secure web networks, WPA2, which is a bit obsolete now, so WPA3 would probably be the go-to. And avoid public Wi-Fi, and if you have, use a VPN as well. For more apps and accounts, you install apps solely from official sources. We had a breach in the company I was working on last year, and the breach came from an employee wanted to download Photoshop. He looked at the tutorial on a YouTube video. The link for the download was on the description of the YouTube video. Spoiler, it wasn't the real link to download. So he got a problem with that, and the whole company got breached. They got most of the Jira records, things like that. So big problems on that side. But it is what it is. But it's as simple as that in some cases. So really be careful what you download. Limit permissions. So don't use root if you don't need root at all times. Use this privilege. Don't run daily tasks as admin. Be phishing smart. Always treat an attachment as malicious if you don't know where it comes from. verify the senders, don't enter credentials in clear text or in unknown email, encrypt sensitive data. I mean, probably no one does that, but you can definitely encrypt your disk if you want to. If you need to get your disk, hopefully you don't forget your password or your data is lost. Review your privacy settings on social media. Don't expose yourself too much. Don't put your pictures of yourself online, visual pictures, family pictures, address pictures, birthday information. Anything can be used against you. So I'm not telling you to live in a cave and never turn your phone on, but there is equilibrium that you can have where you can be protected and at the same time have a social life. So detect and respond at the end. Also monitor what your systems are doing. Check your processes. Check for if you have anything that is breached. If you have any bank that is bank details that leaked, anything, change straight away. Contact the people that you need to contact. Change passwords. Rotate your passwords. You know, things that we tell you every day. So I'm not gonna talk too much about that. But most importantly, keep learning. That's really the thing that you need to remember. If you need to remember just something, keep learning. Don't say, "Oh, I know this. I'm not gonna study it anymore," because in cybersecurity, probably more, I mean not more, but probably as much as other fields, it evolves every day. Every day there are new vulnerabilities. Every day there are things that come out. Every day there are people that get hacked, and every day there are people that hack people. So you need to keep learning and keep updated on what you want to see. I don't know if you guys saw, but there was a big problem, well, not related to hack, but with Amazon Web Service very recently that took down a lot of infrastructures because a lot of people rely on Amazon Web Service for hosting their services. So yeah, I don't know how the breach happened. I didn't read too much, but there are problems that happen every day in numerical, related to cyber, not related, but keep learning and keep updated. So the rest of that was the workshop exercises for last week. So this is the end of this lecture today. I want you guys